Good evening, my fellow scientists. It is Monday, September 25th, 2017, and I want to talk to you about the iron battery some more. So the notion here is that iron is cheap, iron is non-toxic, and an iron battery might be something that could be used for stationary applications where weight wasn't such an issue, but expense and toxicity, environmental damage, that kind of thing were a problem. Plus, iron is sufficiently safe that a person could use iron chemistry in their home kitchen and not worry too much about setting something on fire. So for all those reasons, we want to try to build an iron battery. Most batteries have two chemistries, iron and, say, nickel, but we want to avoid that second chemistry for the reasons that it increases the expense and complication of the battery. So how do you do it? How do you build an iron battery? Well, you need an iron anode and you need an iron cathode, iron 3 cathode in particular. I discovered that iron 3 EDTA works pretty well as a catholyte. It accepts electrons, produces a decent voltage, but it also corroded my current collector. So now I'm looking for a new current collector, and I got some feedback from the community here that copper was probably a poor choice. Carbon's probably the better choice. I agree. Carbon's great because carbon does not corrode easily. But carbon is also not very conductive. So a carbon cathode current collector is it's gonna cause a lot of resistance. So I thought, well, maybe I could use copper as just a backing sheet, but I was all geared up to test the corrosion in my system when I realized that there was no point. Not only does iron 3 chloride corrode copper really quickly, but iron 3 EDTA is in an alkaline environment, and that will produce copper oxide even more aggressively than copper 3 chloride would produce copper chloride. Iron 3 chloride would produce copper chloride. So the whole thing is just not even worth trying. The next more corrosion resistant metals for current collectors would be silver or gold. But that kind of defeats the purpose of a cheap battery, doesn't it? If you're building gold leaf into the thing, it's gonna hurt you. Maybe. I ordered some. It's not actually all that expensive because it's so thin and light. Really thin gold foil is probably not gonna break the bank, but obviously I'd rather avoid it. So here's what I'm thinking. I'm gonna rig up a cell with and without a silver current collector, with and without a gold current collector, and we'll just see how much that helps or hurts the performance. And then we'll see whether silver will do it. I'm pretty sure gold won't corrode, but silver, I don't know about silver. So yeah, as soon as those arrive, we will rig up a new cell with the proper current collector, and we'll see how that goes. So if you like that kind of thing, iron batteries, the fun and exciting world of battery chemistry, tune in right here Monday through Friday. We update and talk about batteries and chemistry and energy storage and all that kind of stuff right here in the Allen Lab.